Alright guys, so in front of me I have a real-life periodic table. This is acrylic. I bought this 1 year ago, and I somehow ended up with two. This second one I got for Christmas. My grandma gave it to me, and little did she know that I already had one. But it's still good that I have two of them. But this side is a little bit chipped, and there's some adhesive. And, anyway, let's talk about it. So, the reason why I'm bringing this up is because I wanted to show you guys the elements that I want to talk about that I do not have. Yeah, my full collection of elements is right in front of me, and it's completely active right now, and we have 49 elements, and I got 46 left to go. I didn't mean to say we have them, I have them, because these are all my elements. But when I get older, I may consider selling some of these for a bigger sample, but for now, I'm just going to keep it the way it is now. But the ones I want to talk about are things like the ones right here, these precious metals right here. I hate these elements. Yeah, the ones that I'm pointing to, these are all metals that I think might be the last ones I'll get, because they're extremely expensive, and you can barely afford 10 grams of it. And what you're looking at here is maybe roughly a milligram or something, maybe 10 to 100 milligrams. Yeah, this is maybe like 100 milligrams of platinum you're looking at. And I just do not like them because of that reason. Another one I hate is thorium. Every single sample of thorium I find online is unavailable, and I can't even afford or even find a piece of thorium. Just because thorium is an expensive metal. It is expensive because nobody's making it. And that's because all of its compounds are the ones that are used. So thorium is a pretty cheap element. It goes for about $300 per kilogram. But that's only for like its compounds. It's like the average price of all those. But thorium metal by itself is just difficult to extract, and it doesn't have any commercial uses. So that's why nobody is making it. It's not a good metal to have either. It's radioactive, and radiation is not really that harmful, but it's still something to watch out for. Same thing for uranium. I have some uranium glass. It's because the pure metal uranium is just... I'm just deciding not to buy it because... for a couple reasons. First of all, it's dangerous. Second of all, it will still emit radiation when encased in glass. And for the third reason, it's the law. It's, not legal to own a kilogram of uranium, but if you have like half a pound of it, or less than half a pound of it, then that's perfectly fine. And uranium decays into several radioactive elements, like protactinium, which is why I put protactinium in the spot for in these two spots. I put the uranium glass directly on these two spots, but for thorium, uranium does decay into thorium, but you can easily find more thorium elsewhere. But when thorium starts having more uses, then maybe its price will significantly drop, because the fact that it costs so much is just mildly infuriating. And this rod that you're looking at is most likely thoriated tungsten. And that's because if this was made of pure thorium, then this entire thing would cost like $150 more. And that goes into this one, this one, this one, and especially these three. Barely 25 grams of astatine exist on Earth at any given time, and any large sample of it would evaporate due to its radioactivity and a short half-life of only 8 hours. This makes astatine the rarest naturally occurring element on Earth. But the ones I want to talk about that are not radioactive, ones that I might get pretty soon. First off, we have vanadium. I don't really know too much about vanadium, is because it has way too much of a similar properties to titanium or other metals that are transition metals. Well, it is able to make these weird-looking crystals. Like if you look on this other one I have, you can see a better glimpse of crystals made out of vanadium metal. It's a metal that is quite hard. It's about as hard as titanium, but it's like 5 times more expensive. It's not terribly expensive, but I'll see if I can afford to get a 1-inch cube of it. Because I want to get a 1-inch cube of vanadium, so that way it fits right with titanium and chromium, which I have 1-inch cubes for. And same thing for molybdenum, which I also don't have, but I'll get a 1-inch cube for it because those are pretty affordable. And it might be my next element. And we also wanted to talk about, like, some of the other ones I don't have, like, we got selenium, which is missing from my collection, and same thing for krypton, and all the other noble gases, besides radon, because I have granite for it, because over time, granite can produce radon gas. And as for nitrogen, oxygen, chlorine, and hydrogen, those are just gases that are not really something I'm interested in putting in here, but if I want to have a full collection, then I have to do it, which is what I'll do. Same thing for phosphorus. How on earth will I get phosphorus? It's flammable. It comes in 4 different forms, 4 different common forms, but the rest of them are just less known. Like, white phosphorus is the most dangerous because it's toxic, and it also spontaneously combusts in air. But the one right here is red phosphorus, which is the safest form. But then we got violet and black phosphorus. And violet phosphorus is similar to red phosphorus, except it's a bit more expensive. But black phosphorus is much more expensive because think of carbon being graphite and then becoming diamond. Like, it's very cheap in its graphite form, but in its diamond form, it becomes a lot more expensive. So, black phosphorus is the equivalent of that. So, black phosphorus is still flammable, but it does make a cool option to collect it because it just looks the best out of all of them, I think. But then we got cadmium, which is a metal that is poisonous, and its toxicity is comparable to lead. And mercury as well, but it's a liquid at room temperature. But then we got, let's see what else we don't have. We do not have any of the alkaline earth metals besides magnesium. We don't have beryllium because it's toxic, and inhaling its dust can lead to a disease that can affect you for 20 years. So we'll have to find some other way to get it. But then we got calcium, strontium, and barium, which can react with water to make hydrogen gas. And then we got lithium, sodium, potassium, rubidium, and cesium, which do the same thing. But lithium is a bit like these 3 elements, but for these next 4, these explode on contact with water, and can even spontaneously ignite in air. And moving down to the ones that I don't have, which are down here. Oh wait, I forgot to talk about one. I don't have boron either. Boron might be one of the next ones I'm getting. But anyway, we'll talk about boron some other day. I don't want to bore you guys out. You see, the rare earth metals are ones that I've been focused on lately. And we have these 2, which I have, lanthanum and praseodymium, but I'm missing cerium. I'm also missing neodymium. But those are ones that also are quite reactive with air. Then we got promethium, which is radioactive. And I don't think I've told you guys about promethium yet. It's a radioactive metal that has a half-life of 17 years, but its most common isotope, promethium-147, has a half-life of about 2 years. It's used in atomic batteries, and its salts glow green in the dark, which are used as paint pigments. So, only 500 grams of promethium are present on Earth at any given time, which makes it really rare. And at room temperature, it's a silvery white metal that oxidizes in air, but nobody has really seen it because it's just difficult to make, and it's radioactive. But we do know what it looks like, because it only appears like that for like a brief second. But then we have europium and gadolinium. These 2 elements are next to each other, and I don't have either of those. And those are the last 2 of the rare earth metals I need, besides these 2, and ytterbium. Well, ytterbium is probably one of the next ones I'm getting. But gadolinium is a metal that's used in MRI scans, and many people have reported gadolinium as a highly toxic metal that's injected into them. Well, it is, if you're messing with its salts and stuff, and microscopic flecks of it are injected into you, and it could remain in the body for a while. That's why people reported it for being toxic. But in its solid form, I wouldn't say it's anything to worry about. I don't think it's that big of a deal if it's a solid chunk of gadolinium. And that's nothing to worry about. But as for europium, well, europium is probably the ugliest element on the periodic table. What you're looking at is probably some compound of europium, or maybe some oil that has a chunk of europium on the inside, but I'll pull up a picture for you right now. You see, look how ugly that is. You have a really hard time calling it a metal after that. That's because after a couple minutes of being exposed to air, it turns that ugly mess, and it does not look metal. It does not sound metal either. But then you realize that its hardness is comparable to lead, so you can easily cut it with pliers. And once you do, it looks indeed like a metal, but then it starts becoming ugly. Yeah, hence the symbol of the element. The symbol of europium is EU, which spells out ew. And I kind of agree with it, because it just looks disgusting. Ew! But here's what it looks like in its elemental state. You see, it looks indeed like a metal. It has a slight yellow tint to it as well. And given its extreme reactivity, it is positioned as like the most reactive among the lanthanides. And it is the most reactive rare earth metal. And do you know what it does on contact with water? Well, watch this video.
I'm going to show you guys the reaction between europium and hot water. Europium is expensive to produce, so outside of nuclear power plants and lasers, it doesn't really have that many uses, but it does make some pretty good lemonade.
something you don't want to do. It produces hydrogen gas and europium hydroxide, which makes the water yellow. And like other hydroxides, it's quite alkaline, so I just don't really recommend trying it out. But that's mainly because of the hydrogen gas being produced. That stuff is flammable enough that if you get a match near it, it immediately sets on fire and explodes, which is what happens with these. They explode in contact with water because they produce hydrogen gas, but then the reaction with these generates enough heat that it causes the hydrogen to ignite, and that sets it on fire, and it produces a massive explosion. That does not happen for europium. It's not that too much of an exciting reaction, though. It just bubbles a little bit. So, if I ever get europium for my collection, I'm going to have to put it underneath oil or something, or maybe inside an ampule, because I do not want it to look like an ugly mess like I showed you before. I want it to look like a metal. But then, that is pretty much all I have to say about the elements that are not in my collection yet. They will be soon. The possible elements that I might be getting soon, the next couple of elements are probably going to be boron, ytterbium, gadolinium, europium, or molybdenum, or also vanadium as well. Those might be my next couple of elements. Well, anyway, I will see you guys when I get another element, which will be sometime in September. Bye.